An English language teacher introduced a new method of learning how to spell four-letter words among her nursery 1 pupils. She recorded the number of four-letter words each pupil can spell before and after the new learning method. So this data were recorded. We can help the English teacher to analyze the effectiveness of the new method of learning how to spell four-letter words by stating a null hypothesis that says there is no significant difference in the spelling ability of the pupils before and after the new learning method, which is the treatment. So to do that, looking at this data, we can actually apply a paired sample t-test, which is also known as related sample t-test, because each of these observations were from a single sample. So as such, to test this null hypothesis, we are to use this formula which says T is equal to summation of the difference divided by the square root of the variance, which introduced here as n, into summation of the d square minus summation of the d, and then squared divided by n minus 1. Now, going by this formula for paired sample t-test, we are to compute our difference, and we compute also for the squared difference. Then we substitute our value into this formula, then we'll get our t calculated. So to get our difference, subtract 5 from 2, then we'll have, if this is d for difference, then we'll have minus 3. Here 4 minus 6, then we'll have minus 2. 9 minus 8, we'll have minus 1. 4 minus 5, we'll have minus 1. 3 minus 5, we'll have minus 2. 6 minus 8, we'll have minus 2. Then 7 minus 6, then we'll have 1. Then the next thing is to look for the squared of the difference, d square. So which means we are to square all this number. Squaring this number means we are to times them by themselves, and automatically these negative signs will go off. So here we have 9, we have 4, 1, 1, 4, 4, and then 1. Now, we need to also compute the mean of this data before treatment and after treatment. Computing this mean will help us at the end when we have finally identified our t calculated. So, if we sum up this, then we'll have 34. So, 34 divided by 7, since the sample size is 7, then we'll have approximately 4.85 as the mean for the before the treatment. For after the treatment, if we sum all this, then we'll have 44. So 44 divided by 7, then we'll have 6.26 approximately as the mean for after the treatment. That is after applying the new method. Now we can also calculate our summation of the difference, because within the formula we need to have summation of the difference and summation of the squared difference. So summing this up, we'll have minus 10, and to sum up the squared difference, then we'll have also 24. So we've got all the values needed to substitute into this formula. So we have t is equal to the summation of the difference is minus 10 divided by the square root of n. Our n is 7 because the sample size is 7. So we have 7 into bracket summation of the d squared, which is this. So we have 24 here, minus summation of the d, then squared, which is the difference, that is 10, then squared, divided by n, we know is 7. So we have 7 minus 1. So this implies that t is equal to minus 10. Then we have to now multiply this by this to open the bracket. So we'll have 168 minus, when we square 10, then we'll have 100 all over 7 minus 1, we'll have 6, all this in square roots. So this implies that minus 10 divided by 168 minus 100, then we'll have 68 divided by 6, all this in square root. Then this implies that t is equal to minus 10 divided by 68 divided by 6. Then we'll have 11.33333 continuously. Then we'll have 5 at the end. So then this implies that t is equal to minus 10 divided by, when we take the square root of this number, then we'll have 3.366502. So automatically when we divide this, we have our t calculated is equal to minus 2.970, or automatically 0.71. Now we have got the t calculated, so the next thing is to get our degree of freedom, df, which is equal to n minus 1. So we have 7 minus 1, that equals to 6. So we now go to our distribution table to look for our t tabulated. So our t tabulated at degree of freedom 6 is equal to 2.447 when we use the 0.05 level of significance. So now we compare our t tabulated to our t calculated. So by implication, we see that our t calculated, t cal, is greater than our t tabulated. So for this reason, we have to reject the null hypothesis. So we say our null hypothesis is rejected. So this means that there is significant difference in the spelling ability of the pupils before and after treatment. Now, where the difference lies is for us to go back to the mean scores of before treatment and after treatment. Before treatment, we have 4.85 as the mean score or mean spelling ability. Then after treatment, we have 6.25, meaning that there's a significant increase in the spelling ability when the new treatment or the new learning method was introduced by the English language teacher. Hence, so the new learning method is effective in enhancing the pupils' learning ability and spelling. Thank you very much for listening. Then we'll meet in our next lesson.